Welcome to this tutorial on AWS Secrets Manager, part of our AWS Security series. In this video, we'll explore how to manage application secrets securely in the cloud. Secrets Manager is a powerful service that helps developers and DevOps teams store sensitive information like database passwords, API keys, and authentication tokens without hard-coding them into application source code. By the end of this tutorial, you'll understand how to store secrets securely and implement automatic rotation to maintain a strong security posture. AWS Secrets Manager is a fully managed service designed to protect access to your applications, services, and IT resources. It provides centralized secret storage, allowing you to securely store database credentials, API keys, and other sensitive data in one place. One of its most powerful features is automatic rotation, which has built-in capability to rotate secrets without causing application downtime. All secrets are encrypted at rest using AWS Key Management Service, or KMS, with fine-grained access control through IAM policies. Additionally, Secrets Manager fully integrates with CloudTrail and CloudWatch for audit and monitoring, enabling compliance tracking and security event logging. Let's understand how secrets are stored securely in AWS Secrets Manager. The process involves three main stages. First, when a secret is created, plain text data is submitted either via the API or through the AWS console. Next, KMS encryption takes place, where the secret is encrypted using an AWS KMS customer master key. Secrets Manager uses envelope encryption with a 256-bit advanced encryption standard symmetric data key. Finally, the encrypted data is stored securely in a highly available backend infrastructure. It's important to note that secrets are encrypted both at rest and in transit, and Secrets Manager maintains version control for all secret values, allowing you to track changes and roll back if necessary. Creating a secret in AWS Secrets Manager is straightforward. You can use the AWS command line interface with the create-secret command. You need to specify the name parameter, which serves as a unique identifier for your secret. It's recommended to use hierarchical naming conventions like prod/database/mysql-credentials. The description parameter allows you to provide context about what the secret is used for. The secret-string parameter contains the actual sensitive data, which can be formatted as JSON key-value pairs or plain text. Secrets Manager can store up to 65,536 bytes of data per secret, which is sufficient for most use cases, including database credentials and API tokens. To retrieve secrets from your applications, you'll use the AWS SDK for your programming language. In this Python example using Boto3, we first import the Boto3 library and create a client for the Secrets Manager service. Then we call the get-secret-value method, passing the secreted parameter, which is the name or ARN of the secret we want to retrieve. The response contains the secret string, which holds the decrypted secret value. It's crucial to remember that your application needs the appropriate IAM permissions to retrieve secrets. Specifically, you must grant the Secrets Manager :get-secret-value permission to the IAM role or user that your application uses. Secret rotation is a critical security practice that helps reduce the risk of compromised credentials and meets compliance requirements. But why should you rotate secrets? Regular rotation limits the window of opportunity for attackers if credentials are compromised. The rotation strategy in AWS Secrets Manager involves a Lambda function that automatically updates the secret value and changes credentials in the target service like a database or API endpoint. You can enable automatic scheduling to configure rotation intervals ranging from 1 hour to 365 days based on your organization's security needs. More frequent rotation provides better security but may increase operational complexity, so it's important to find the right balance for your environment. The rotation process in AWS Secrets Manager follows a 4-step workflow executed by a Lambda function. In Step 1, create secret, the Lambda function generates new credentials and stores them as a pending version in Secrets Manager. In step 2, set secret, the Lambda function updates the target service, such as a database, with the newly generated credentials. In step 3, test secret, the Lambda function validates that the new credentials work correctly by attempting to authenticate with the target service. Finally, in step 4, finish secret, the new version is marked as current and becomes the active secret, while the old version is deprecated but retained for a grace period. If any step fails, Secrets Manager automatically retries the entire rotation process to ensure reliability. Let's conclude with some essential best practices for using AWS Secrets Manager effectively. First, apply the principle of least privilege access by granting minimal IAM permissions needed per application. Each application should only access the specific secrets it requires. Second, enable rotation for all database and API secrets to automate credential refresh and reduce manual intervention. Third, monitor access to your secrets using CloudTrail to audit all secret retrieval operations. This creates an audit trail for compliance and security investigations. Finally, use naming conventions by organizing secrets with consistent hierarchical paths like environment/service/credential-type. This makes secrets easier to manage at scale and improves overall security governance. By following these practices, you'll maintain a robust and secure secrets management infrastructure.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.